Hey, I'm Morgan. I'm a product manager here at SCIAPS, and we're here to talk about handheld XRF and handheld libs.
And my name's Ben Boutour. I work with SCIAPS as well, here with Morgan.
So Ben, I heard you like rocks.
Guilty as charged.
Tell me about that one.
So this is a pegmatite sample from the North Carolina tin spodumene belt. So this is it's an igneous rock. It's generally chemically a granitic composition. So it's mostly quartz, feldspar. It's got some pyroxene. It's actually got quite a bit of spodumene, and then some kind of associated minerals as well. So I think one of the things that Morgan's going to show here with the libs is how to identify which mineral it is.
I'm not a geologist, but I can tell you this is a rock, and I could use your help understanding. What should I point at here? Exactly. What should I be pointing the libs at to, if we're mining for lithium or exploring for lithium, what are the interesting parts on this rock to?
Yeah, so we think this white mineral here might be spodumene.
Yeah,
so basically it's pretty simple. If we see lithium light up in element Pro, along with silicon, aluminum, a couple other elements, lithium is a key identifier. So if we see lithium, it's spodumene. It's not going to be albite.
So I think we're talking about this kind of area. There's a little circle there as well. You had circled earlier. So we'll definitely test that. But I'm kind of curious. We have this other rock. I see a similar white spot here that looks a lot like the white spot you just pointed me at.
Yeah.
They both look white to me. I can kind of see, this one's a little milkier than that one. But could this be spodumene too? What do you think?
Let's find out.
So what's cool, I think, about the Z-903 and all of our libs here is that we've got this camera that's pretty high resolution. We can see exactly what the laser's going to hit, basically. So we can really get some kind of pinpoint accuracy on the sample and where we want to test. So here we can kind of see that's just the edge of the white mineral you were pointing out. I'm just going to pull the trigger. We'll do a quick test. All right, so I know this isn't quantifying anything, but how would you interpret these results?
Yeah, so we're seeing some sodium, some silicon. It's a silicate rock, so silicon's going to be there. You can test it again just to get another
let's give it a
shot on it. But that leads me to believe that it's likely not a spodumene.
Yeah, that looks pretty similar. I'm seeing the same set of elements up at the top of the screen.
And so what this app does is it basically identifies which elements are present in the sample. So it looks for spectral peaks, and it says, okay, this is sodium, this is calcium, this is potassium, and then it tells you if it's high or low.
Yeah.
So that RA number, relative abundance, it's not a percent, it's not a ppm. So it's just a kind of almost a proportional representation. It's telling you, there's a lot of this element or there's a little bit.
Now let's switch back to the bigger sample here. There's another spot kind of right here that looks, to my untrained eye, it looks pretty similar in color. Let's give it a shot with the libs and see what we can see. So just align it, and then I'll pull the trigger. So that's very different to me. What do you think?
Yeah, so that's almost like kind of the the flip scenario. So we've got really high lithium. We did pick up a little bit of sodium. It's only seeing 50% of the sodium lines. So you have to sort of use your judgment on that a little bit and say, okay, we're seeing 100% of the lithium lines. It's really high. It's really high. So there's likely a lot of lithium there. A little bit of sodium, so that's likely a spodumene.
Okay, so you're going to bet it's spodumene.
Yeah, that's probably a pretty safe bet.
How much are you willing to bet?
Oh gosh, I will bet this piece of lithium ore that.
All right, I'm rich, but I think you're right.
If we want to cheat a little bit, we've got some kind of specimens here of this is a pure albite mineral. So why don't you shoot that and see what that turns up with.
Give it a try.
So there we go. We've got, sodium, aluminum, silicon, potassium. So really no, a little bit of lithium as well, again, but
it's not up at the top like when we shot the spodumene, right?
that's right.
Yeah.
So we've also got a piece of spodumene here as well.
Oh, nice.
So we can.
Okay.
So yeah, really
again.
quickly we're seeing, okay, it's obviously not, a positive identification. We're not doing mineral ID or fingerprinting, but it's essentially giving you some good clues. It's another, like we said earlier, another set of eyes on the sample.
And what's cool, I think, is that it's fast. I mean, it fires the laser, maybe 20, 50 times in that amount of time, and it's just a fraction of a second. And then just like that, we've got a list of elements there, and including lithium, which you can't really do with anything else in this kind of extremely portable way, right?
Yeah, exactly.
So I think, although this won't identify the mineral positively, if you kind of know what you're looking at and you can piece it together with the elemental information you're getting out of the libs, it can be really valuable.
Absolutely, yeah.
Great. Well, thanks, Ben.
Thank you, Morgan.